Calculus, Unit 5, Day 40 notes. Our objective, distinguish between the instantaneous rate of change of a function at a point and the average rate of change of a function on an interval. Extending these ideas to understand and apply the mean value theorem and Rolle's theorem. And hopefully you remember last lesson we talked about the extreme value theorem. Okay, let's go. Okay, so we are now going to look at the derivative as a rate of change. Again, what is the derivative? It is the slope of the tangent line. What is slope? Change in y, change in x. It is the rate of change. So this is going to lead into the mean value theorem and Rolle's theorem. So consider the values of a differentiable function f of x in the table below to answer the questions that follow. Plot the points and connect them on the grid below. So let's do that first. In calculus, the derivative has many interpretations. One of the most important interpretations is that the derivative represents the rate of change of a function. Let me just underline that right here. Okay, and when speaking of rate of change, there are two rates of change that can be found that are associated with a function. Average rate of change and instantaneous rate of change. So average rate of change of f of x on an interval. So right down below it says find the average rate of change of f of x on the interval from 2 to 12. So to do that, let's find point 2 is right here. Point 12 is right here. And again, this is 2, 5, and this is 12, 8. And so the average rate of change, what we're actually going to find out is that this is the secant line. And the secant line whose slope is equal to the average rate of change of f of x on the interval from 2 to 12. So this average rate of change of f of x on an interval, which an interval is going to include more than one point, that's going to be the slope of the secant line. And on an interval from a to b, the average rate of change is found by f of a minus f of b all over a minus b. That is the slope formula, change in y over change in x. So for this specific rate of change, it's going to be f of 2 minus f of 12 all over 2 minus 12. And again, change in y, change in x, you can do y2 minus y1. It doesn't matter which one of these you start with as long as you start with the same x coordinate. F of 2 is 5, f of 12 is 8. That'll be negative 10. And we're going to find out that this slope is going to be positive 3/10. This will be negative 3 over negative 10, which will be positive 3/10. Okay, now we're going to look at the instantaneous rate of change of f of x at a point. And I'm going to look, let's look when down bottom it says at x equals 4, and we'll start here. When x equals 4, I'm right here. And there's my tangent line. And then we're going to eventually compare this to x equals 6, this tangent line. And we're going to answer some questions about that. So again, average rate of change, which is going to be the slope of a secant line on an interval, and the instantaneous rate of change of the function at a point, tangent line. And again, this instantaneous rate of change at a point is the slope of the tangent line. So at any value, x equals a, the instantaneous rate of change, again, it's the slope of the tangent line. What is that equal to? That's equal to the derivative at that point. So is the instantaneous rate of change of f at x equals 4 greater than the rate of change at x equals 6? Justify. Well, again, what's the slope of the tangent line at x equals 4? That looks like that's greater than the slope of the tangent line at x equals 6. So I know f prime of 4 is greater than f prime of 6 because the tangent line is steeper than the tangent line at tangent line is steeper at x equals 4. It's steeper at x equals 4 than it is at x equals 6. So that's my justification. Again, tangent line steeper at x equals 4 than the tangent line at x equals 6. When we look at the diagram again, there's x equals 4, then it's slowly getting closer and closer to this maximum, which will be 0, so we know it's less steep at x equals 6. Okay, and that's what we're going to use for instantaneous rate of change. So instantaneous rate of change, slope of tangent line, average rate of change, slope of the secant line.